projections of planes. So here this is the standard procedure for solving any planes problem. All the planes problems we can split into 4 cases. Here I am showing the first case. In this first case, surface is inclined to HP, edge is inclined to VP, and the edge is in the HP. This is the first case. So while solving the planes problems, you have to identify the surface inclination and edge inclination with respect to the reference planes. So here in this case, surface is inclined to HP. So you have to keep the surface parallel to HP. So always we have to keep the surface parallel to the reference plane to which it is inclined. In this case, it is inclined to HP. So make it parallel to HP. Next we have to think about the edge. Edge is inclined to VP. So you keep the edge perpendicular to VP. So when the surface is parallel to any of the reference plane, then the surface is said to be in the simple position. Always we have to consider the simple position in the first stage. So here I am drawing the simple position of the solid. When the surface is parallel to HP, we will get the true shape and size of the surface in the top view. So I am drawing the top view here first. ABCD is the pentagon. I have drawn the top view. From the top view, I have to project the front view. While projecting the front view, you have to think about the position of the edge. In this case, it is given that edge is in the HP. When the edge is in the HP, you are keeping the surface parallel to the HP, means entire surface will be on the HP. So you will get the front view on the XY line. Suppose the edge is parallel to the horizontal plane, means automatically this front view comes some distance away from the XY line. So here this is the simple position. After simple position, you have to represent the surface inclination in the second stage. Here I am going to the second stage. In the second stage, I am representing the surface inclination here. So I have tilted the surface to some angle 45 degrees. Then I am drawing the projectors from the front view. I am drawing the locus lines from the previous top view, and here the reduced shape of the surface is seen in the top view. This is the second top view. So here edge inclination is given. Edge is inclined, that's why I am keeping this edge perpendicular to VP from the first stage onwards. So automatically this edge perpendicularity will be shown in the second stage also. Now in the third stage we have to represent the edge inclination. So to represent the edge inclination, I have to reconstruct the second top view. Now I am reconstructing the second top view here. Now observe, at an angle of 60 degrees, I have reconstructed this second top view. This is the final top view, that is third top view. From this top view I am drawing the projectors, something like this. I am drawing the projectors. From this second front view, I will draw the locus lines, something like this. Draw the locus lines, and automatically the final front view has obtained here. This is the final front view. This is the first case. Now we will go for the second case. The difference between first case and second case is edge parallel to HP. This is the only term that is deviated from the first case. Surface is inclined to HP, that is similar to first one. Edge is inclined to VP, this point is also similar to first one. And edge is parallel to HP. This is the second case. In the first case, edge is in the HP. Now observe the difference. Edge is parallel means after keeping the surface parallel to HP, we will get the front view some distance away from the XY. Somewhere here we will get the front view. In the previous case, we are getting the front view here on the XY. That is the only difference between the first case and second case. Now as usual, in the second stage you have to tilt the surface. For representing the surface inclination, you have to tilt the front view here then we will get the reduced shape in the top view. Then represent the edge inclination. I am tilting this top view to some 60 degrees. I am reconstructing, then drawing the projectors and locus lines from the previous front view. We will get the final front view. Okay, so answer is same. The shape in the final stage what we have obtained in the first case and second case is same. Only difference is in the second case this edge A dash E dash will not touch the XY line. This will be some distance away from the XY line. Now we will go for the third case. Now see the third case. In the third case, surface inclined to VP, edge inclined to HP, and edge in the VP. So here surface is inclined to VP. So according to our standard procedure, what we have to do, we have to keep the surface parallel to VP. So identify the surface inclination with respect to the reference plane and you make it parallel to that particular reference plane. Identify the edge inclination with respect to the reference plane and you keep the edge perpendicular to that reference plane. Surface means parallel, edge means perpendicular. Now when the surface is parallel to VP, we will get the true shape and size of the surface in the front view. So we have to start our problem from the front view. After that, obtain the top view. Here top view lies on the XY line because one edge is in the VP. So edge is in the VP means when we are making the surface parallel to VP, the entire surface will be in the VP. Then automatically we will get the total top view in the XY line. Next, to represent the surface inclination in the second stage, now you have to tilt the top view because in the top view we are seeing the surface as a line. So when you are tilting this line means automatically you are tilting the surface. Now reconstruct this particular line here, draw the projectors. From the first front view draw the locus lines and obtain the second front view. So in the third stage we have to represent the edge inclination. To represent the edge inclination, you draw one line with the angle of the edge, then reconstruct this second front view in that particular angle and draw the projectors from the front view, locus lines from the previous top view and obtain the final top view. Now we will go for the fourth case. Fourth case is just similar to the first case. The only difference is here edge is parallel to VP. In the previous case edge is in the VP. Here in this case edge is parallel to VP. Surface is inclined to VP means we have to make the surface parallel to VP. When the surface is parallel to VP, we will obtain the true shape and size in the front view. So we have to start our problem from the front view. While drawing the front view, how to keep this edge? Whether it is parallel to XY or perpendicular to XY means it is perpendicular to XY because edge is inclined to HP. So we are keeping the edge perpendicular to HP. Then front view we have drawn. From the front view to obtain the top view, while drawing the top view, this top view will be some distance away from the XY line because this edge is parallel to VP. The edge is not in the VP, the edge is parallel to VP. When the edge is parallel to VP, some distance in front of VP means we will get that some distance below XY line. Next, to represent the surface inclination, you tilt this to some angle. Here I have given 45 degrees. I am reconstructing this particular top view in 45 degrees angle, drawing the projectors and drawing the locus lines, and the reduced second front view is obtained here. Next, to represent the edge inclination, draw a line representing the edge inclination and along that inclined line reconstruct this second front view. Then automatically we will get the third front view. From the third front view draw the projectors and from the second top view draw the locus lines. Automatically we will get the third top view. So these are the standard 4 cases. If you thorough with these 4 cases, you can solve any problem in projection of planes.